All right, and lastly, let's look at one more example for this section, and then you guys will have a test next week on chapter 5. All right, so it says, find all the solutions in the interval from 0 to 2 pi, so this should be in parentheses, from 0 to 2 pi, of tan of x over 2 minus sine of x equals 0. Okay, so we know about half angle, double angle formulas. Let's see what we want to use. Now, if I look at all the formulas, I have a half angle here. So that would kind of put me in this category where I'd have to use the half angle formula, which has that square root. And I don't really want to deal with the square root in this fraction. So I'm going to change a little bit using u substitution. So we're given tan of x over 2. I'm just going to do a little u substitution and say, you know what, let my u be x over 2. Then it won't look so complicated. So I have tan of u minus sine. Now I don't want to put x because that'll give me a different variable. It becomes difficult. So I want to figure out what this is in terms of x, right? What is my x going to be? So if I multiply both sides, do this, by 2, I end up with 2u equaling just x. All right, so instead of writing sine of x, I'm going to put sine of 2u. So I took out my angles, used u substitution, so I have 2u is x and have 1u is x divided by 2. Right? That just helps me to not have to deal with half angle formulas. Now I can say, well, we know what tan of u is. It's just sine over cosine, but sine of 2u, now I can go to the double angle formulas and say, oh, I have a double angle. I know that sine of 2u is 2 sine u cos u. So I'm going to replace it. So I have tangent u minus, this guy replaces to 2 sine u cos u. Right. And so I don't really want to have to deal with all these different trig ratios in one problem. So I'm going to change this to sine and cosine terms. So tangent is sine over cosine. We still have minus 2 sine u cos u. All right, and I'm still kind of simplifying as much as I can. Right now, this is over 1, right, because it's a whole number. So I'm going to multiply it by cos over cos so that I get a common denominator. So I'm going to multiply the numerator by cos u, denominator by cos u, so that I can put this all as one fraction. So this first piece here didn't change. It's still sine u over cos u. And then minus 2 sine u cos u times cos u again is going to be 2 sine u cos squared u all over cos u. Now that I have common denominators, now I can say let's put all this together. It's still equal to 0. So I have sine u minus 2 sine u cos squared u all over my denominator of cos u. Right, and because I'm trying to solve for u and ultimately get back and solve for x, I need to make sure that I'm kind of trying to isolate these equations as much as possible. So I'm going to use factoring. Right, so we could actually do a little bit of cross multiplying right now so I don't have this fraction. Right, if I were to multiply both sides by cos u, or kind of cross multiply, I would end up with sine u minus 2 sine u cos squared u. Right, numerator would stay the same when I multiply by 1, and then equals 0. Right. And then now I can say, well, now this looks a little bit easier. I have a sine u and a sine u. Let me factor that out. And I end up with 1 minus 2 cos squared u. Right, and now I can split up my equation. I can say, well, I have two different factors and it's supposed to be equal to 0. Either sine u equals 0, or this factor of 1 minus 2 cos squared u equals 0. All right, so either this factor of sine u equals 0, or this factor of 1 minus 2 cos squared u equals 0. And then we go and solve. We say, well, when is sine equal to 0? There's only one place, well, not one, there's two places on the unit circle where sine is equal to 0. So we're going to say u is either at, if we look at our unit circle, draw it here, u is either at 0 degrees, right, because the point here is 1 comma 0, or pi. Right, so we can say 0 comma pi. And we have to go back and say, well, u was not what I was given. I used u substitution to make the problem easier for me. So let me go back and say, what was u supposed to be equal to? Oh, it was equal to x over 2. Ultimately, I was asked to find the value of x. Okay, so I need to go back and replace u with x over 2. So instead of u, I'm going to put x divided by 2 is actually equal to 0 and pi. And those are two equations we can solve. If we just multiply both sides by 2, we'll get x by itself. Multiply by 2. There are two answers here, so I'm just kind of doing them all at one time. So x is either 0, 2 times 0, which is 0, or 2 pi. And I do have to make sure that I'm sticking with my range. My answers were supposed to be between 0 and 2 pi. Remember, I changed this. This is supposed to be parentheses here. So I don't want answers up to 2 pi. I want everything between 0 and before 2 pi. So that means from this factor here, the only answer I actually got was 0. All right. This guy's a little bit too far out of my range. Just didn't quite make it. All right, so 1 minus 2 cos squared u equals 0. I'm going to solve that one again. If I add 2 cos squared to both sides, I end up with 1 equaling positive 2 cos squared u. And then I'll divide by 2 on both sides, cos squared u. And then I can square root, so I get the square root of 1/2 equals cos. And because I took the square root myself, that means I have the plus or minus. All right, but we know that the square root of 1/2 is the same thing as root 2 over 2. And we know where cosine is root 2 over 2. Right? What angles is cosine root 2 over 2? All the 45s. So that means I'll do them in radians. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4 are all my possible answers for you, because all these are the places where cosine is either positive or negative root 2 over 2. Okay, and if you don't remember that this is root 2 over 2, just rationalize the denominator, get that 2 out of the denominator, and you'll see that it's the same as root 2 over 2. But again, just like this one over here, u is not what we started with. We started with x over 2, so I need to make sure I replace u with x over 2. So that means x over 2 could be all these possible answers. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And you could split them all up. There's 4 different options. And just like I did on this side, I'd have to multiply because I don't want x over 2. I want just what's the value of x. So I'd multiply each of these guys by 2. Right? I'm kind of taking a shortcut here, not wanting to write all 4 of these answers out. So then I get x is 2 pi over 4, which is pi halves. 6 pi over 4, which is 3 pi halves. Right? If you reduce it down. 10 pi over 4, which is 5 pi halves. And 14 pi over 4, which is 7 pi halves. Those are all my possible answers for x. And again, just like I had a couple answers here, but I had to eliminate the numbers that were out of my range, I need numbers between 0 and 2 pi. So this is a half pi, 1.5 pi, so those are good, but this is 2.5 pi. That's over 2 pi. This is 3.5 pi. That's over 2 pi. So these guys are not in my range of answers. So the only answer I'm getting from here is pi over 2, 3 pi over 2. These are my 3 possibles. X could be 0, could be pi halves, could be 3 pi halves. Okay, so we're using our formulas so that we can actually go back and solve again for some additional trig equations. All right, so that ends the chapter. So make sure that you are looking out for that chapter 5 test and letting me know if you have any questions when we meet on Wednesday morning.